So, what is keratoconus? Normal vision, uncorrected vision, corrected vision. So you can imagine how I can see, okay? A candle, when looked at, appears like a number of lights confusedly running into one another. The pattern depends on the day. When I wake up one day, I see the pattern of the day, okay? One letter, by the way, I cannot distinguish the left from the right. I know that the left is one A and the right is many A's, okay? The images move relative to one another in time with heartbeat. Now, the only advancement after Hellenistic science about eye is this one. We now know how many layers constitute a cornea. This is very important mechanically speaking. You have the epithelium, which is the only thing which is regenerated every day. Then you have the Bowman layer, the stroma, the Descemet membrane, and the endothelium. The eye is a nervous tissue. The number of cells with which you are born will remain always the same during all your life. Now, if you want to understand why the vision is so complicated, look at the typical histopathology exam of corneal stroma affected by keratoconus. Imagine what light is doing passing through this chaotic structure. Okay? Now, I wanted simply to list the genes which Indo-European people have degenerated, causing this keratoconus. And on the right side, you can see the digital image reconstruction of the shape of a normal cornea and a keratoconus cornea. This is a genetic disease because if you have a parent, sibling, or child with keratoconus, you have up to 60 times higher risk in developing this pathology. This is the, by the way, in order to know that this is the sagittal curvature, I needed some time because, you know, for these people, the medical doctors or opticians, curvature is curvature, full stop. I asked them, Gauss curvature, mean curvature? After a while, I discovered that this is sagittal curvature. Remark, please remark, that the bubble is always down. So there should be a relationship with weight. I mean, and we have troubles in understanding how this relationship is to be established. Okay, I don't see the figures, but I remember that you can see here how light rays are distorted because of, on the right, the degeneration of cornea shape. Okay? Okay, now I tell you a little bit about, nobody knows anything about etiology, but the description of the cornea of the eye. So you have the cornea. Then you have behind the cornea, you have the iris. Between iris and cornea, you have the chamber which is filled with humor aqueous. The cornea is connected mechanically to sclera. Behind the iris, you have the lens. Behind the lens, you have the corpus vitreus, then you have the macula on which retina is glued. Okay, just to make it short, with a very small mechanical action, which unfortunately I applied to my cornea, which was very weak. I will tell you how weak it was later. I have broken the cornea, lost all the liquid in the chamber, broken the iris, displaced the lens, and broken the corpus vitreus. Luckily, the retina is still there. Otherwise, I could be lost. By the way, this is a problem rather expensive. I calculated that if I had this accident in the United States, the cost would have been more than 250,000 euros. So before complaining about taxes in Italy and France, consider this, okay? I pay 1/2 of my salary for taxes, but I'm happy of that. Okay, so this is the bulging of keratoconus, okay? And we want to understand better the mechanics of it. Okay, by the way, another important thing which may be crucial in understanding the mechanics of this object is that the back corneal surface and the front corneal surface have different shapes in keratoconus. So if you look at the right, you see the corneal thickness, and if you look on the left, you see the sagittal curvature. Okay? By the way, without the I will try to involve my good friend François in the big problem of developing a code for digital image recognition, because, of course, they cannot reproduce the shape of corneas easily. Okay, as I am a philosopher of Magna Graecia, I tell you that Herophilus, the biggest doctor in Hellenistic science, described the cornea and the sclera. The names were given by him. By the way, you know why Herophilus could get all these results? Because he could get people who had to be killed because of crimes, and he could do experiments in vivo. And this is very helpful if you want to know. Okay? But of course, as I said with Anil yesterday, if you have a pig, as the eye of a pig is very similar to human eye, you can do experiments in vivo. So instead of buying a 3F35, which, by the way, can be easily blocked by Trump, we could spend the money for studying a little bit these things. Okay. How important was Herophilus? He discovered the iris, the retina, the choroid. By the way, retina means that it is like a casting net. Okay, Fallopius said that Herophilus autoritas apud me circa res anatomicas est evangelium. For me, the authority of Herophilus about anatomy is like Bible. Okay? Unfortunately, not a lot more has been done after Herophilus. For instance, nobody knows why retina is detached, how retina works, why glaucoma happens. These are diseases which cannot be cured now. Okay, what is penetrating keratoplasty? You take the inner part of cornea and you cut a donor's, of course a dead eye. This has to be done in the first 15 minutes because after half an hour, after some time, the cornea is completely lost. And then you sew the cornea with stitches, as the suture is described as you see there. The big problem is the crown you see around remains your cornea with keratoconus degeneration. Now the problem is how to optimize the surgical act to get the final best optical shape for transplanted cornea. Okay, this was my right eye, the good one. You can see that the thickness was in a place 220 micrometers. The standard thickness is 520 micrometers. So it was very weak. Okay? The young modulus of a keratoconus cornea is 27 kilopascal. An healthy cornea has a young modulus of 50 megapascal. So you can understand why you should never touch your eyes for any reason if you got this kind of transplant. My left eye, through which I see now, not very well, is even more unstable because there is a part where it is 130 micrometers. Now, there is no metamaterial which is capable to have the refractive power of a cornea. The cornea has a refractive power of 43 diopters with a thickness of 520 micrometers. It means that 10 micrometers have an optical power of 0.82 diopters. There is no material which we know capable of doing that. Okay? Now, as I have already said to Francois, these were the digital image correlation of my corneas before the accident. As you can see, they do not know anything. You lack information. It is nearly empty. Okay? So we need to improve at least the software for digital image correlation. Okay, now mechanics. Albeit the stroma is a very complicated structured material with reinforcing fibers and a transparent gel. By the way, do you know why we see a certain range of wavelengths? This is dictated by the distance between the fibers which are reinforcing stroma. So the window of light which we can see depends on the structure of stroma. Okay, now if you try to model a cornea with a 3D continuum, the numerical simulations become so long that with actual tools you cannot do in an efficient way. So what we did, we formulated a reduced order model, but we start from a 3D Cauchy continuum model. So we have a placement in 3D. The idea was we take an elliptic plane, an plane ellipse, and an interval minus L0 plus L0 over 2. Okay. We map this in the current placement of every material point of the cornea. Then we introduce the standard reference configuration vectors, capital E1, capital E2, capital E3, and then we have the current small e1, e2, e3 vectors. We calculate deformation measures, Cauchy green deformation, standard Cauchy continua, green Saint-Venant tensor, and then we introduce a deformation energy functional. We assume a nonlinear deformation, which is simply quadratic in the nonlinear deformation measures, just for starting the analysis. And then we apply the inner pressure. Inside the eye, you have atmospheric pressure plus between 10 and 15 millimeters of mercury pressure. And we added a weight. Okay? By the way, we are not using any curved reference configuration. The reference configuration is flat, so the normals small n to the surface must be calculated with the standard Piola formulas. By the way, Nanson was born 3 years after Piola was dead. So calling this Nanson formula is possible only if you are Anglo-Saxon. Okay. Then, as it is not very thick, the placement can be described in this way. So you have a linear dependence on a capital X3, and we also assume that the stiffness tensor can be decomposed additively as you see there. Okay, then you start doing calculations. I'm not offending you, telling you trivial tensor algebra. Okay, and at the end of the story, we discovered that the deformation measures are gradient of the thickness d. So d is a vector which we introduced here in this formula, which will become another kinematical descriptor of the reduced order macro model. Okay, gradient of norm d square f transpose d, and then all these quantities you see there. Okay, so that the Green-Severin tensor can be represented in this way. Okay, so at the end we can write the deformation measure as a surface integral in terms of the 3D deformation measure, and you see in the last two lines the definition obtained in the gradient between minus L0 and plus L0 over 2 of the volume deformation energy. Of course, we needed to calculate everything with Mathematica because explicit formulas are useless. I mean, you can show them, but they are very... Then you impose the boundary condition, and for doing things easy, albeit not mechanically very meaningful, this assumption must be improved. You get essential boundary condition. So you impose on the boundary of the cornea the displacement and the thickness. Okay? We need to know the constitutive equation of a cornea. Okay. These are the transversely orthotropic material symmetry parameters, and I must tell you, and we must give to Caesar what has to be given to Caesar, the group led by Anna Pandolfi studied very carefully this important problem so that we know more or less which constitutive equations has to be used for corneas. Okay, then we started numerical simulations. So we imposed a pressure and we got a beautiful form of normal cornea. So parameters could be fitted, and we have all these, say, interior and exterior surface of cornea shapes. Okay. Then we started with the first assumption. We assumed that damage was affecting C0, and we assumed that you have a priori the localization of damage down. Now, the question is that this sounds to me rather like an ad hoc assumption. I mean, why down? If you have a degeneration of a cornea, why it degenerates always in the same point? I demanded to biologists, to medical doctors, and they told me that there is no biological reason for which the damage should be concentrated there. Okay? But in this way, we get rather reasonable shapes with this ad hoc assumption. Okay, then we have discovered that if the damage affects C1, you don't see any effect on the cornea. So the damage must be related to C0, not to C1. Okay. Then we invented an effective weight. I must tell you that we estimated the weight of the humor aqueous, the cornea, and this weight alone cannot justify this effect we see here. However, I have heard, and then I found in the literature, a theory. They claim that the lids apply a force on the cornea which is equivalent to a weight. Our lids are very strong, and they can apply up to 20 millimeters of mercury force. But this is not a pressure. It has a direction. And the component, the vertical component, is rather important. So playing with that, this point has to be improved in our analysis. We could get very nice patterns without any a priori assumption. Okay? So these shapes are the shapes of the keratoconus. By the way, let me sadly joke. The reviewer told that our simulations, that is Ivan's simulations, were not reliable because the young modulus of the crown of keratoconus residual cornea was too weak compared with the young modulus of the central part of the cornea. Okay. It is 2,000 times weaker. We have found in the literature evidence about this. As I'm stupid, I wanted to test experimentally this. Okay? Okay. Now, we need better digital image correlation, this I already said. The elastic moduli in penetrating keratoplasty now are made like that. You have a crown with weaker coefficients, and inside you have stronger coefficients. Okay? And we have these calculated shapes after a successful keratoplasty. And this is the plot of the thickness of the transplanted cornea shape. And this is in agreement, qualitative agreement, with our measurements. Now, consider that the thickness manages to be very low. Okay? Now, I don't see nearly anything in this picture, but I think that you should see the superposition of the calculated shape over the measured shape of my X right cornea. Okay? And we needed to make the elastic moduli very low. And you can see the effect of becoming thinner in some part of the cornea. The thickness became very thin. Okay. And these are the measurement, the thickness forecast thicknesses in the transverse and sagittal plane. Now, the bad cornea we couldn't fit very well, probably because of the fact that to make things complicated, on the left eye I had a rejection, which had to be cared with a lot of medicaments. So you have this, you see on the left, a very thick scar connected with a very thin keratoconus cornea. So probably I will tell you what we believe to do. Possible reasons of the partial motor failure. The host corneal tissue had an initial smaller thickness. The boundary conditions used are not appropriate. Sclera and corneal tissue are connected in a more complicated way. High gradient of deformation influenced the final corneal shape, so probably higher gradient continua must be introduced. The hypothesis of cylindrical symmetry must be abandoned, because my cornea, left one, is very irregular. It's not cylindrical symmetric. Opaque part of transplanted corneal tissue have a very different mechanical behavior. So I am at the conclusions with few minutes of delay. So two possible damage effects of keratoconus pathology on corneal shapes are considered. Their plausibility needs to be checked with further clinical evidence. And I think that what has to be underlined is that here we have high gradients of deformation concentrated at the interface between donor and host corneas. So I think that this boundary layer needs to be modeled in a better way. But also, if you want to forecast the success of a transplant, you need to know the initial thickness of the host cornea, which we didn't consider. We assumed that it was 520 micrometers at the beginning. Okay? Okay, now I think that I said everything. And look, I will survive also with one eye, but let's hope that the fingers of eye doctors will be good enough for restoring the optics of my right eye. But you know, the big problem is that if they don't take time for studying, they will not be guided by a theory, and this is very detrimental for advancement of science. For instance, the images which I've shown you are very rare, because albeit the machines are available now, they cost 1 million euros. But you know, you can have one machine in a place and you send all the patients there. In Rome, there is no such machine. I need to go to Nuremberg for getting these measurements. Moreover, Do you know why I can publish this paper? Because it is my cornea. I cannot publish the image of somebody else's cornea. I mean, how can we proceed? I don't say that we must go back to experiments in vivo. Okay, but what is bad if I publish images of a cornea? There is no name of the person there. Okay. My optician in Nuremberg told me that he has 600 images. But he risks to go to prison and lose his job if he gives them to me. Okay, thanks a lot for your patience.